Okay, today I thought we'd take a look at the Venus robot and the Jupiter robot side by side. And the reason for that is when you just see pictures of them separately in books and online, you don't realize that they're a different scale. The designs of the feet and the lower parts of the body and everything look identical, and you figure they're both going to be the same scale. You can see here they're not. Now both toys were sold in handfuls of different colors, and the Jupiter robot was this is the wind-up version, was also sold in the battery remote version. And I guess what I was getting at is I was trying to find a robot out here that might be fun to design in CAD and then 3D print closely based on one of these robots. So initially when I came out here, I'm going to move this camera back a little so I can step in between the camera and the toys. I was going to see if I used a double, this is for 2 AAA batteries, which one of these might work out better. And it looks like on the Jupiter robot you might be able to fudge a battery holder into the back, and it wouldn't really matter if it went sideways or vertically. It seems to be about the same distance. You know, the interesting thing about the Jupiter robot, which I think I've talked about before, and I keep with my Robbies, is because you can see this on the side. This looks like the Robbie mouth, the tube, and the upper lip. So it's like they took a Robbie head from the sides and put them both together to form one head, and then move the ears, of course, there. So it's like a double Robbie type setup. On the Venus robot, which I know I've done a video of in the past, it's on a wired remote, and you can see it's quite a bit smaller, and it would be very difficult to incorporate a battery thing in there unless you moved it far enough in that it actually went up into the head, or maybe extended the back of the head out further to accommodate the battery holder. Has a single D cell battery in its remote. So I'll push the button there and you can see that it's not a bad walker. And the Jupiter robot, let's see if it's wound up. Nope, we'll wind her up some. Jupiter robot, by the sound of it, I can hear in the gears, could use some lubrication in there, but it is walking. Let's turn it upside down so the flint's not rubbing, see if it changes the speed any. Not really. There is a flint mechanism up in here which would spark every now and then. Most of that chirping sound though is the sound of gear shafts that could use some lubrication. I could have wound it up more too, but as it is, I didn't want to stand here all day waiting for it to finish running. At least it has an on-off switch on it, so you can turn it on and turn it off. So I'm not really sure if I'll redesign either one of these as a 3D printable project. I might. This boxy head version, this would be easier, and I could use the little teeny N20 dual shaft motor that I've been using recently, because it would fit in there. But I think we'd have to stay with some sort of remote, wired remote. This one could either go with an N20 and probably fit the battery box in. We might even be able to, because of the tall head, going in with the T-type motor. I'm trying to decide, maybe you could use the 48-to-1, because there's enough room. We might be able to do one gear reduction down before it gets to the legs to slow it down so it would run better. It would be more complicated to design this head, but this is probably a better scale and shape for trying to fit the batteries and everything all into the robot. As you can see, the legs are just cosmetic. They pin them in the middle here. So that means you've got dual linkages going up for the ratchet wheels. And then this leg part just slips over that. I have to give it some thought. But they could make for interesting 3D printed projects.